Welcome you all to the LabVIEW programming environment video tutorial. Today we are going to see and understand this graphical programming environment which is called VI. Let us have a head start on the basic features of LabVIEW and its tools. Stay tuned and follow the instructions to learn this programming software faster. Let's begin. When you click on the LabVIEW button, this is the screens which you see. When you come over here, it will ask you whether you have got to open a blank VI or blank project. Let us create project here. Let us click on the create project button. So once we create the project button, it will again ask us whether we have got to create a blank project or blank VI. We will stick on to blank project and then we will click on finish. Once I click on finish, the project window opens up. Now I'll click on file and I'll click on new VI. So I'm going to click on new VI. You can see that two windows opens up. One is a gray window and one is a white window. Now let me click on this Windows tab to arrange these two windows, that is a white and gray window side by side, that is vertically. I will arrange it. I'll click on this tile left and right. Let us see what happens. There you are. You have arranged now two screens, that is a gray window and the white window side by side, so that when you start programming you will be able to see what is actually happening. VI stands for virtual instrument, and if we look on this screen here, you can see that I have already started a VI, a blank VI. A VI is made up of these two windows. One is the gray window and the other one is a white window. The gray window is called the front panel, which serves as a user interface. Serves as a user interface for the LabVIEW program, and the white window over here is the block diagram, which serves for the functional graphical code that you create in Lab. If I right click in the front panel, you can see that a controls palette or a group of functional libraries comes in picture. It's termed as a controls palette. And if I right click on a block diagram, you can see another set of functional palettes comes in picture, or functional libraries comes in picture, which is called functional palette. Right, now let us identify what is the difference between these two windows. Let me give you an example. Take the example of this oscilloscope multimeter. This is an example of an instrument which can control and also it can display a waveform. So it can control and it can also display. That which we normally use in this part of the instrument is the control and a display. That is what user does. User controls and also watches the output as a display. But is that all an instrument is all about? No. Instrument has got a lot of things inside. It has got hardware, electronic components, it has got software, it has got a lot of mathematical operation happening. So there is a lot of engineering behind it. All those user interface which we talk about in an instrument, as I've told you, this is a virtual instrument. Virtual is something which is not real. We are making in a computer program the virtual instrument. In the virtual instrument, the same interfaces, user interfaces must be available. So where are those available? In this front panel, all those user interfaces like controls and displays will be available, and all those related to the internal structure, that is functions, mathematics, all those hardware related things, all those operations, that is all the engineering operations, is done in the block diagram. Right, now let us see the use of LabVIEW in a broader picture. LabVIEW for process control. To understand process control in simple words, let us take the example of a tap and a bucket. The tap must be turned on to fill the bucket. The flow rate will determine the length of the time. When the bucket is full, the tap must be turned off. So this is a simple process control which we can take, wherein which the flow of water through the tap determines how much time it takes for the bucket to be full, and when the bucket is full, the tap must be turned off. This is a very simple process control. We can extend this process control to a very broader picture, like manufacturing might be a car automatically, wherein which everything related to start of the manufacture of the car parts to the end of getting the car ready, everything is automated. So that is also a process control. Here we are going to see a very simple process control. On the left you can see it's already, the code is already running. Let me just show you what will happen. You can see a knob over here, a gauge, a water level slider switch, and a tank level indicator. Let us see what is going to happen when we change. So what is that I'm going to represent here? With the upper part, I'm going to represent, this is the upper part, I'm going to represent this as accelerator knob, and this is a speedometer gauge which you can see in your vehicle. And this is the second one which I have shown, that is the second part. Here I have got a slider, water control slider, and I've got a tank level, water level. When I move the slider, this water level has also got to change. Similarly, when I move this knob, this speedometer gauge has got to change. Let us see what is happening. It's already in the run mode. To run the mode, you must click on this run button. It's already in the run mode. Let us see what is going to happen when I move the knob. So you can see that when I move the knob on the right, the dial is also changing. You can see one more thing. Above 8, you can see that the red button goes on, and below 8 you can see that green button is on, and below 2 you can see that yellow button goes on. What does that indicate? It indicates always, so you know, when you are running your vehicle in optimal speed, it always shows green, and when you are above particular speed where in which the fuel efficiency is lower, you will see a red indicator. Here we have also introduced a yellow indicator indicating again fuel efficiency is low during that point. So this is a control and an indicator which you can see on the left hand side. Left hand side, what I control is controller, and on the right of the gauge which moves, you can see that over here, that is the indicator. You have got again 3 other indicators, lamps, which also lights up at different levels. On the bottom you can see a slider, water control slider. When I move this water control slider, on the right you can see that the tank level also goes up and low. Let us increase it to a higher level. You can see that when I increase to a higher level, a high level alert is turned on here, and when I take it down, you can see that the high level alert has gone, and when I lower it to a lower level, you can see that the low level alert is turned on. And also there is one more thing, when you can see it over here, when I move in the slide, water level indicator also changes. It is a water level normal now here, and when I increase, you can see that when the red light turns on, the water level is high, is also indicated as a string. And in the similar way, when I reduce it to lower place, you can see that low level alert has turned on, and also water level is low indicator, a string which is being shown over there. This is basically a very simple program which has been developed for you to understand a basic process control when you are developing a project. These are the ways you will develop it. So this is just one part of the program. As I've told you, this is a user interface, the front panel. Now there is something on the background, the program, the real program. Let us see the program now. When I click on Control T, I'll be able to see the program also aligned vertically. You can see that I clicked on the Control T, and you can see the program on the right hand side aligned properly. So let us not discuss the program now. It can still be made more complicated with improvement in the functional block in the user interface. Let us not make it more complicated, and we will not be discussing also at this particular point. Here the objective of showing this particular project is for you to understand what is the level of projects which we can get done with. Right, now let us see how LabVIEW graphical programming works. Now that I have removed my project from the screen, let us start fresh with the controls palette and drop in user interface functions. Now for getting the controls palette, you have got to right click on the front panel, right click, there you are. You can see the controls palette which has come in. There are a lot of functions over here which you can take in from the controls palette. You can see that this is a group of function. Each of the functions which you see in the controls palette, like numeric, boolean, string and path, all are a set of functions. When you put your cursor over it, you will be seeing the set of functions which is there inside. So let us go to numeric first. So when we go to numeric, you can see that there are still a lot of functions inside. Let us click, drag and drop some of the functions into the front panel. Let us first click the knob function, click, drag and drop. There you are, comes our first function on the front panel. Let us click another, again to numeric. We'll click on gauge this time, drag and drop. Right, again we'll go to numeric, we'll click on vertical point slider, drag and drop. Again we'll go to, this time we'll go to graphs. Let us go to graphs and click on waveform chart, drag and drop. Next we will go to strings. In the string functions we will go to string indicator, drag and drop. If you notice that every time I drop in an item on the front panel, there is a corresponding terminal that appears on the block diagram, but it is not connected with each other. So let us make some modifications with this. We can change the size of the things which you have already added, like selecting all and then dragging this blue button over here, and you can make it little bigger. Again same, you can select a particular component, put it in its place and then rearrange it by dragging it, making it bigger. Similarly, every component you can do as per your like, so that it is well arranged in your front panel, so that it looks better to visualize it. Right, so this is a string. Again I can put it in, yes. So we have arranged our front panel. Now we have got to arrange the block diagram. Let us see. You will be able to understand which is that component on the right hand side, or which is related to the component on the front panel. Like when I double click the knob, you can see that the knob gets highlighted. When I double click the gauge, you can see that gauge is highlighted. Similarly, when you double click every component on the front panel, you will be able to see that particular component on the right. But it has got to be connected to each other. It has got to be wired to each other in the block diagram. If we need some movement of the things when we move the knob, if we want the gauge to be moving, we need the functional components on the right to be connected to each other, so that when we run, when I move on the knob, the gauge starts moving. So let us make those connections now. For making the connections, you have got to take your cursor near to the knob. You can see that a wire tool comes in picture, and now drag and connect it to the gauge. There you are. So now I have made my first wiring in the block diagram, wherein which I have connected the knob to the gauge. Let me wire the second one. Take your cursor to the slide, so you can see that it is getting highlighted and the wire tool comes in picture. Click on your left click and then drag and connect it to the waveform chart by releasing it. When you reach the waveform chart at the right point, release it. So the wiring is done. Now the third part is a string. String is a set of letters which forms a word. This is a string display. For displaying something, you need something at the input. So let us create an input for the string. Put your cursor over the string, right click, go to create constant. There you are. Let me drag and drop this, drag to little far and put it over there. Now let me put some words inside the string constant. Double click on the string constant inside and then put hello world. There you are. Now our all components are ready for running. For running, you can either press the first run or the second run continuously. The first is the normal one which we have got to use for our programming, but the second one is a simulation, wherein which if you want to run it continuously, you have got to press on this. If you want to run continuously in run mode, you have got to modify the code. That we will see on later. Let us now stick to the run continuously for the time being, but keep it in mind that we normally don't use this run continuously in our programming. We will be using run in our programming, and we have got to make that necessary modifications in the program such that our programs run continuously. For the time being, let us click on run continuously. So now our program is running, and when I move now the knob, you will be able to see that the gauge is also moving accordingly. Similarly, when I move the slide, you can see that the waveform comes in picture. When I increase, you can see that the waveform goes up and goes down, and you can see the string which was blank before, now the hello world which was in the constant has come in the string indicator. So that is our first program. That's the end of this video tutorial. Hope all of you have enjoyed watching this video. Let's meet again in my next video. All the best for your online learning sessions. Thank you.